When working in Jupyter Notebooks, there are several ways to perform nonlinear least squares fitting to a model. In this video, I'm going to show the use of lmfit. And I'll start with some basic background on least squares fitting. And chi-squared is essentially the sum of the residuals. So when you minimize chi-squared, you are minimizing the difference between the model and the data that you're fitting to. So typically how this is done is to make an initial guess at the variables that you're fitting, and then the algorithm will find which way is downhill if you were visualizing these variables on a 3D grid. So then it will continue to change the variables until the chi-squared no longer decreases. And then one potential problem with this is having a false minimum, so a local minimum instead of the global minimum. And one way that this can be avoided is to provide an initial guess. And I'm not going to discuss this algorithm in this video, but for those who are interested, lmfit is based on the Levenberg-Marquardt algorithm. So I will first go over basic plotting. To plot, you first need to import matplotlib. So I'm going to say import matplotlib.pyplot as plt. Then making a plot is very simple. The command is plt.plot, and then you will have your x variable, your y variable, and then to make it a scatter plot, instead of having the lines connected, you just use this O. Tip that I have is to make your x and y variables as arrays instead of lists. And this is especially helpful if you are going to manipulate the values in any way, for example, do a normalization. So to make an array, you need to import numpy, and I'm going to import as np. And then I'll show two ways of making an array. In the first, I'll start just with a list in the x variable. And then if you already have a list defined, you can then just say np array, and then simply put the variable in parentheses. Another way to do this is to directly make an array. So for example, I'll say y equals np dot array. And then for this, you need to have parentheses and then brackets, and then your values. So that's two easy ways of making arrays. So now I will plot these. And some additional things you might want to add to your plot are a title, X and Y labels, And sometimes it might be nice to add a grid to your plot. So this is how my basic scatter plot looks. And now I will get into curve fitting with lmfit. The first thing you'll need to do is to install lmfit. So you do that with this command. And you'll need to do this once per session when working in Jupyter notebooks. So you can either have this in a separate code cell or just comment it out after you first do it. And the first thing when working in lmfit that you need to do is to define the function. So the syntax of that is to say def, and then you'll have a function which you can name whatever you like. Then you will have some variables in the parentheses. The first variable always has to be the x-axis variable, and then the following variables will be the variables that you are fitting to. Then you need to have a semicolon. In the next line, you indent and type return. And then after return is the equation, whatever would be after the y equals in the equation. So for my example, I'm going to be fitting to the Michaelis-Menten equation, which is V naught equals V max over 1 plus Km over substrate concentration. So I will say define, I'm going to call it MM for Michaelis-Menten, X, and then the variables that I will be fitting to are K and V. So after the Y variable is what you put here in return. So I will say V over 1 plus K over X. And I'm just calling it X here instead of S. And then I'm going to just paste in some values for my X and Y variable. The next thing you need to do is import model. So to do that, you say from lmfit import model, and then you tell it what model you want to use. So model, actually it's just mod equals model, and then here my model is MM. Then to do the fitting and to get the results, you say results equals mod dot fit. Then you'll have your Y variable first, then your X variable. I'm going to say X is equal to S, which I defined right there. And then for the variables that you're fitting to, you can provide initial guesses, and the default guess, if you don't have an idea of what these will be, the default is 1, and that usually, for most data sets, will be good enough to get an accurate fit. Then to get a plot of your data and your best fit line, you say result.plot. So this will give you your data, the best fit line, and the residuals. To see the fit statistics and the final fit of your variables, you just type result. So that will give you these statistics and the variables that you fit to, as well as a correlation. And if you want to output the variables that you fit to, one way to do this is to use results.best values, and then you tell it which variable you want, and then you can print this. With your units. And this will take the value from your fit and print that. So for example, if you were to change the values that you're fitting, this will automatically give you the new variable. One thing you'll notice is that the best fit line just connects the points, the same number of points as in the number of points that you've given in your X and Y values. So to generate a smoother line, you can simulate more points in the best fit line. To do that, you what do you say, result.plot, but then you give it a number of points. For example, I'll say 100, and then you get a much smoother best fit line.